One way that we apply differentiation is in calculating related rates of change. So distance, velocity, and acceleration. When we know the distance, then we can use that information to calculate the velocity by differentiating. And when we know the velocity, we can use that information to calculate the acceleration by differentiating. Let's have a look at some examples. This example says the displacement of a particle moving in a straight line is given by the equation of motion. S is equal to 5t cubed plus 3t plus 8, where t is measured in meters. Find the velocity after t is equal to 2 seconds and find the acceleration after t is equal to 2 seconds. So we're being given the equation of motion, which is the displacement, yeah? And we're being asked to find the velocity. So we're going to go back to our charts, yeah, to use our charts to help us. So we have the equation S is equal to 5t cubed plus 3t plus 8, yeah? And we're being asked to find the velocity after 2 seconds, yeah? So the first thing that we want to do is differentiate, yeah? Remember our charts. If you've been given the displacement or the distance, you can use that to find the velocity by differentiating. But in this case, it's going to be the S over the T, because we're talking about S and T, time and displacement. Okay, right. The S by the T would give us the velocity. The S by the T is equal to the velocity. So if we differentiate 5t cubed, remember we have to times by the coefficient of x, we have to times the power by the coefficient of x, and then reduce the power by 1 always. So that will give us 15t squared plus 3. This time we have no power, and if we reduce the power by 1, that will come to 1. So everything will just be 3 times 1, which is equal to 3. And after t seconds, after 2 seconds, we just have to substitute 2 whenever we see t. Substituting when t equals 2, and 15 times 2 squared plus 3. This is going to give us 15 times 4 is 60 plus 3 is equal to 63 meters per second. Remember, we're talking velocity, so velocity would be meters per second. And it also says to find the acceleration. Yeah, the acceleration means that we have to remember the chart, blah, 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 yeah? We have to find again, differentiate again. This time, it's going to be the square S over the T squared. Okay, that is the acceleration. And so if we differentiate this one again, we're going to have 15 times 2, that would be 30t. And if we differentiate a number, it comes to nothing, it comes to 0. So then after substituting after t equals 2 seconds, we would have 30 times 2, which is equal to 60 meters per second square. Okay, remember this is acceleration, so it's meters per second square, and this is velocity, so it's just meters per second. So that's the example that I have. That's that example done. Okay, those are the two. That's the first solution, and that's the second solution. This example says if S is equal to 10 plus 5t minus 2t squared, where t is the distance traveled in t seconds by a body, what is the speed of the body after 5 seconds. So here you've been given the distance to be this s is equal to 10 plus 5t minus 2t squared, and we're being asked to find the speed. Okay, the speed is like the same kind of like velocity. Okay, so again, the first thing that you want to do is to differentiate. The s by the t would be equal to 10 comes to nothing, 5t comes to 5, minus 2t squared comes to 4t. This is 5. Now that we've got the derivative, of this one, which is the velocity equation, which is the velocity or the speed, which is the speed, then we can substitute 5 seconds to see what the speed is after 5 seconds. So after 5 seconds, yes, write that here, by the t would be equal to 5 minus 4 times 5, which is equal to 5 minus 20, which is equal to negative 15. Okay, meters per second.